record, so this meeting is going to be recorded, and
Okay.
you will get a link later on today that shows you how to watch that session.
Okay, thank you.
Okay. All right, so if you're going to verbalize them, we can get started. What are we doing today?
So we moved into like verifying equations.
Okay, one of my favorite things to do, verifying trig equations.
Yeah.
All right,
So
let's
I
have
got like some homework problems, and the first one is 2 cosine squared of x plus cosine x minus 3, and then like over negative 2 squared of x, or negative sine squared of x, sorry.
What's that all supposed to equal?
And that equals 2 cosine x plus 3 over cosine x plus 1.
All right. Well, they don't start you out with easy ones, do they?
No, not really.
All right, let me look at this for a minute.
Well, we've been doing it for like a few days, so we had a few easier ones, but now it's kind of ramped up.
Yeah, all right. It looks like we can factor the top. Usually what you do on these is you do the more difficult side and try to make it look like the other side.
Uh-huh.
Okay. Now, you don't have to do that. There's no rule that says you can't manipulate the right side and make it look like the left side. But
Yeah.
let's try it the first way first. If I factor the top, that looks factorable. It looks like it must be this. No. Minus 3 plus 1. No, it gives a minus. It's got to be this way.
Wait, how did you get that?
How did I factor it?
Yeah.
Notice what you're looking at in the numerator is a quadratic.
Okay, yeah.
It's a quadratic because the first term is the square of the second term. That's all you really need to have a quadratic. In other words, over here on the left, that's also a quadratic. Because e to the x squared is e to the 2x. Okay, so lots of things will fit the formula of a quadratic, and when they do, you can factor them. Let's see, this has to be plus 3 and minus 1. And now we produce that middle term of plus cosine x. With me?
Yeah.
Okay. Now, that's kind of helpful because if we're trying to make it look like the right side, well, let's see, what can we do with the bottom? Sines? Go ahead.
You have a 2 cosine plus 3 already on the top, so you just have to get rid of the cosine x minus 1, right?
Well, here, let me rewrite this. I ran out of room, so let me, make it a little bit clearer.
Okay.
Yeah, there's the 2 cosine plus 3. There's the 2 cosine plus 3. So what we really need down the bottom is something that will handle this other. But that's not really even the way to think about it. Let's think about using the Pythagorean identity for sine squared. What is it?
Cosine squared minus 1.
Now, factor that. That is the difference of perfect squares. Don't ignore this negative sign, but leave it over there for a moment. Okay?
Okay.
We don't want to have it get mixed up with what we're doing. Right.
Okay.
So I'm going to put that back in. And then this factors how?
You have cosine x minus 1 and cosine x plus 1.
And now you can see where we're going.
Ah, yes.
Now, this negative sign has to be applied to one of them. Ooh, weird. In other words, this is what we have now, right?
Yeah.
That cancels with that, and now we have 2 cosine plus 3 over cosine x plus 1.
Which is the...
Well, no, it didn't. We still have that negative sign.
Oh.
You sure?
So...
You sure there was a negative sign in front of the sine squared in the denominator?
Yes.
All right, let's go back and revisit sine squared. Ah, I see what's happened now. We didn't factor that. We didn't put the right identity in for that.
Oh.
Okay.
My bad.
Sine squared plus cosine squared equals 1. Therefore, sine squared equals 1 minus cosine squared.
So
minus sine squared would equal cosine squared minus 1. In other words, if I want to move this sine squared to the other side, becomes minus sine squared. I move this 1 to the other side, and that's what negative sine squared is equal to, is cosine squared minus 1, which then factors into cosine minus 1 times cosine plus 1.
yeah.
Now, that cancels with that, and we're left with what we have on the right side. This is the way I usually do my trig identities. I work down the left side, and once it matches what the right side says, I draw an arrow to it.
Okay.
Okay? And you'll notice one other shortcut I tend to take when I'm doing these is I leave out the x.
Okay, yeah, I see that.
Only because you're writing it so often, you can save a lot of work by not writing the x and just writing it like I've kind of done this 2 cosine plus 3.
Okay.
Not that I'm recommending that, it's just offering a tip that if you're working it on your own, if you have to show all your work, then you probably should put in the x. And if you run into trig identities where there's 2 variables, then you definitely want to put in the x. In other words, you might have an x and a y, and then we wouldn't want to omit it. Okay?
Okay.
Okay, so the solution here was factoring.
Yeah.
Ended up factoring the top, using the trig identity for the bottom, and then factoring the bottom, canceling.
Yeah.
Piece of cake. What else did you got? This time I'll start far enough to the left.
Okay, so cotangent squared of x times cosecant squared of x minus cotangent squared of negative x equals cotangent to the 4th of x.
Is that it on the right?
Yeah, that looks right.
Okay.
Yeah.
So let's take the thing that gives us the most difficulty at the moment, and that's having a minus x inside the parentheses.
Okay.
Is this an odd or an even function?
That is an even.
Okay, it's actually odd. Cotangent is the reciprocal of tangent, and tangent is odd. Remember, odd means that it is symmetrical with the origin, not the y-axis. Even means it's symmetrical with the vertical y-axis.
Okay.
Okay? So the fact that that's odd means that that part of the equation I could write as minus cotangent of x times minus cotangent of x. Right? In other words, all I've done is taken that and turned it into what it really is. In other words, cotangent of minus x is minus cotangent of x.
Okay.
Okay. Now, when I square that, I get cotangent squared of x. So actually, that is the same as cotangent squared of x. So let's that change immediately.
Mm-hmm.
That first minus sign still applies.
Yes.
Okay, let me erase this rest of it here. All right, now, whenever you see something, I can see that factoring is the big thing here. Okay.
Yeah.
What can we do to the left side in terms of factoring?
You should condense the two terms. Oh, but for factoring first,
think greatest common factor always is the first thing. Whenever you think you should factor something, start with greatest common factor. If there's no greatest common factor, then see if it's a quadratic. If it's not a quadratic.
Not a quadratic.
Not a quadratic, but there is a greatest common factor.
Is it cotangent squared of x?
What term is in both of those pieces?
Cotangent squared of x.
Exactly. So that's what I'm going to factor out. What's left?
Then you have cosecant squared of x minus 1.
That's huge. Now, what do you suppose that identity is?
Isn't it equal to tangent? No, wait, 1 second.
Here's the way I remember it here. Rather than have you look it up, I'd rather you do it this way.
Okay.
Don't want you to look it up. I'm a real proponent that if you always look up stuff, you never end up memorizing them.
Yeah.
Okay, so that's the tangent Pythagorean identity. Well, the cotangent is very similar looking, only it's the cofunctions.
So it's cosecant, yeah.
Now, what is cosecant squared minus 1 equal to?
Cotangent squared.
In other words, when you're doing these things based on these identities, you rarely find them in the format that you learn them.
Yeah.
You just, it's not that simple. Yeah, in other words, you find 1 minus cosine squared. That's what you find. Or you find secant squared minus 1, or cosecant squared minus 1. Well, we're looking at cosecant squared minus 1. What's that equal to?
Cotangent squared.
So now we have cotangent squared times cotangent squared.
Yeah.
That's equal.
Which is cotangent to the 4th. Yeah.
Exactly.
Mm-hmm.
Okay. So far, there's a very common theme in all of these, and that is factoring and Pythagorean identities.
Yeah.
Okay, you got another one?
Okay, this one's a hard one. So, cotangent and then parentheses pi over 2 minus x. And that is over cosecant of x minus cotangent negative x times negative x.
Cotangent of negative x, you were correct.
Yeah, of negative x.
Not times.
Okay.
Okay, in other words, it's a little bit like saying that's f times x. It's not. It's f,
Yeah.
f
Um,
of x. In other words, that's just a designation for a function that is a function of x. But it's not multiplication, and this is not either. That's
okay.
cosecant of x, and that's cotangent of minus x. Okay? Now, let's talk about cofunctions. How are cofunctions? What's the cofunction of sine?
Cosine.
Yep, that's the definition of cofunction. What's the cofunction of cosine?
Sine.
Okay, and here's what's true. With all cofunctions, both of these are true. Okay, so this is true with sine and cosine. What's the cofunction of tangent?
Cotangent.
So tangent is equal to cotangent of pi over 2 minus x. Notice that if I draw my 30-60 triangle, what's the sine of 30 degrees?
1/2.
What's cosine of 60 degrees?
Also 1/2.
Ah, that's true for all these cofunctions. That's why these cofunction properties are true.
That makes sense.
That's why any trig function, same thing with tangent. Tangent 30 degrees is 1 over square root of 3. The cotangent of 30 degrees, the cotangent of 60 degrees is also 1 over square root of 3.
Yeah.
And that's true for all triangles, whether it's a 30-60 or a 31-59. Okay?
Okay.
These cofunction properties are important. Okay, so let's see, did we ever get to the right side of this equation?
Oh, not yet.
Hold on, let's go ahead and write that.
Okay.
Although, could almost bet that I can figure out what it is.
Okay.
Should we try?
Sure.
Okay, so what's cotangent of pi over 2 minus x using the cofunction property?
So wouldn't it just be tangent of x?
Yep, so that's tan of x. Now let's look at the denominator. Let's look at the tough part. What's cotangent of minus x?
Just cotangent of x.
No, remember cotangent is odd,
No.
so it's negative cotangent of x, which is going to give us two negative signs.
Which would be positive.
All right, so that becomes cosecant x plus cotangent x. I'm going to take a wild guess and say that's what's on the right side.
I actually have
Okay,
secant of x minus 1.
okay, that's okay. We'll get there. Secant x minus 1?
Yeah.
Total, like that?
Yep.
Okay, that's fine. Let's go back and manipulate this equation a little bit. What is cotangent x equal to? Now, when you're looking at these as to what identity to use, if it's a squared, then you usually are going to use the Pythagorean identity. If it's just a cotangent of x, use the reciprocal identity.
So this would just be a cotangent of x, so then its reciprocal would just be tangent.
Yes, watch what happens. Tangent of x all over cosecant of x plus 1 over tangent of x. Now, how do I handle the bottom? What I have to do is find a common denominator and add those two terms together.
Okay.
Okay, so I'm going to do this. I'm going to go left to right just because I don't want to lose too much of the top here. So this becomes tan of x all over, well, the common denominator is going to be tan of x, right?
Mm-hmm.
And then up here, this must be what? Cosecant x
plus 1.
tan x plus 1.
Plus 1.
Okay. Now, you see how he did that? In other words, when I found the common denominator, those are the two fractions we were dealing with. That one and that one. The left one is exactly what I started with, cosecant x. And the right one is what I started with, 1 over tan x. So it's always useful to do that check just to make sure you've added those two fractions together properly. Okay, now I have a rational quotient in my denominator, so I can flip and multiply.
Yeah, multiply reciprocals.
Okay, so this becomes tan squared in the numerator, cosecant x tan x plus 1 in the denominator. And this all has to equal secant x plus 1?
Minus 1.
Minus 1? Hold on. And one thing you've probably learned about these verifying trig identities, sometimes you can completely go in a wrong direction.
Yeah, and get way off track.
You kind of get stuck, and then you have to go back and almost start the whole thing from the start with a different strategy. There's one rule that they tell you that if all else fails, convert everything to sine and cosine and do it that way.
Okay.
Okay. Well, all hasn't failed yet. Let's see. What can we do? The top. We can write the top in terms of secant. Can we not?
Yes.
We're looking at a tangent squared, so let's replace that with what it is. What is it in terms of secant squared?
Is it secant squared minus 1?
Yes, it is.
Okay.
And that's going to help. You'll see. So, how are we going to get rid of that secant? Jeez. Let's look at the bottom again. The bottom. Cosecant, what's the reciprocal of cosecant?
Sine.
So that's 1 over sine. What's tangent's quotient identity?
Quotient identity? What do you mean by that?
Sine over cosine?
Oh, yeah, fundamental identity, sine over cosine.
Sine over cosine. We're making progress.
Oh, and then you can cancel.
Okay. Now, that leaves us, and notice that I end up with 1 over cosine, right?
Yeah, just
secant. So now here's what I have on the left side. Secant squared x minus 1 all over secant plus 1. Now, can you see what I need to do next?
Can you cancel one of the secants out?
Factoring. No, you can't. Be careful about trying to cancel. First of all, you can't do that because the numerator has 2 terms in it. And
okay.
The denominator has 2 terms in it. It would be like saying if I told you that x plus 1 divided by x minus 1, you cannot do that.
Yeah, you can't cancel the x's, yeah.
No. If everything's being multiplied, then you can do stuff. But if you're adding and subtracting numbers to it, that makes it a lot more complicated. However, what is the top? What does that look like?
It'd be secant x minus 1 and secant x plus 1.
Yes, always learn to recognize difference of perfect squares. Secant x minus 1 times secant x plus 1. Now see what's going to happen.
You can cancel out the plus 1.
And you're left with there like that. Okay?
Perfect.
So not all trig identities are most easily done by converting them to sines and cosines. We might have been able to do that, although, boy, the secret that I usually use is if I'm not looking at any sines or cosines in the original, then I don't go that way, unless I have to.
Okay.
Okay?
Yeah.
There's no doubt
Similar.
in my mind what needs to be done with that. That needs to be turned into tangent. That needs to be turned into negative cotangent of x. And then what I did after that was merely add fractions in the denominators. Once I get it to a single fraction, I can flip and multiply and see where that takes me. And I didn't really know where it was going to take me on this. And at first I thought for a second I may be on like a wild goose chase, but it turned out that it was the correct way to go about it. I'm quite sure that this was probably the fastest. By fastest, I mean fewest number of steps. That's really the only thing that determines if one way is better than another. As I think I told you when I was at your house, there's no practical usage where there's no real world usage where you have to verify trig equations.
Yeah.
Only one purpose of it. It's like a drill. It's like a tennis drill. It's to improve your trig identities. And boy, these do it. You do these verifying identities for an hour, a couple days a week, and you'll know your trig identities like you know the back of your hand.
Yeah.
And it accomplishes that. It's a great drill. It's a little like flashcards. I suppose one way to do it would just be to make up a bunch of flashcards and work with your trig identities. But this is almost better. This requires more than just trig identities. It requires a little bit of creativity. A lot of times there's techniques that are not totally obvious. One that you're probably familiar with is if I see something like that, let's say I had something like that. And I got to start doing stuff to it. The one thing that's not obvious at all that you frequently have to do is multiply by the conjugate.
Yes, we learned this.
Okay. And what multiplying by the conjugate does is turns that into the difference of perfect squares, right? In other words, you then end up in your numerator with that. And then that turns into sine squared.
Yeah.
So you get to take this term here, which is very difficult to deal with, and by multiplying top and bottom by the conjugate, you turn it into a simple single term that's much easier to deal with. Now, it's true that in the bottom, we would then have 1 plus sine x times 1 plus cosine x, but you'll find out that's not as hard to deal with as it looks. Usually there'll be something that takes one of these out. Okay?
Would you fold?
Well, without having an actual problem, it's hard for me to illustrate this principle. But one of the principles that you wouldn't intuitively think of doing. In other words, if I gave you something like that, you'd probably just start searching for the reciprocal of cosine, put it in there, reciprocal of sine, put it in there, and then do all the arithmetic. So it's a bit of an unusual approach, but it's one that whenever you see 1 minus cosine or 1 plus sine, notice that if I wanted to turn that into something practical, I'd multiply it by 1 minus sine on top and bottom. And then that would turn the bottom into 1 minus sine squared, and I could substitute cosine squared for that.
Yeah, that makes sense.
Whenever you see a term that looks like this, 1 plus sine or 1 minus cosine or even cosine minus 1 or sine minus 1, think of that technique.
Okay.
Okay. Well, it's 4:04, so
Yeah.
we've done a half an hour. I will let you go, and
But,
hopefully that gives you a chance to see how my online works. Um,
okay.
and
And then,
go ahead.
okay. Do I need a new like ID every time we do a session?
Yes, you do. And
Okay.
what I do is text that to you rather than call you each time.
Okay.
What is your cell phone, Lauren?
Oh, 720-648-1784.
And that's what I should text it to?
Yeah,
And
that sounds good. And then I'll just type it in.
the other number is like your house number? Is that your mom's cell or?
Is it the 303 one?
Yes.
Yeah, it's my mom's.
Okay. So I'll just change that on my thing. Yeah, the next time, couple of minutes before the meeting, I will text you the 9-digit meeting ID number, and
Okay.
you already have the icon on your desktop. So
Yep.
double click that icon, put in the meeting ID number. You don't have to do anything else. Then you're,
Perfect.
well, you may have to, I don't know, but I guess it does kind of force you to put your name and email each time. I'm not sure
Oh,
whether
that's not
whether it memorizes that or not, but you'll
okay.
have to see. Um, and you figured out how to schedule online.
Yep.
You're good to go. Oh, one last thing. Let's see. I think I have your right email. Firebeast17, is that you?
Yep, at hotmail.com.
At hotmail.com, right.
Yeah.
I will send you the link this evening to your email that will let you see the recording of this session.
Perfect. Thank you so much.
All right, Lauren, have a good rest of your weekend, and I'll talk to you next time.
Thank you.
All right, bye-bye.